All right, it's 1 past the hour, and we're going to go ahead and get started. I'm having a little bit of technical trouble getting my video to show up, so my apologies for that. My name is Nathan Heston, and I'm one of the trainers here at Briggs Stratton Energy Solutions. I'm joined by my colleagues Mike Schaefer and Daniel Moyer. We hopefully will also have Quinn he's a product manager, Quinn Weber from Sol-Ark, joining us here in a few minutes as well. But we're going to go ahead and get started with the slide deck. So welcome, everyone. We look forward to walking through these slides and introducing SimpliPHI 6.6 battery backup, as well as Sol-Ark inverters in our packages to you this morning. So let's go through. So the objectives of this training are to define what an energy storage system is. An energy storage with solar and generators typically refers to a battery system. So we're looking at battery backup solutions, and we're going to be identifying what those components are in a battery backup system. We'll also describe the differences between the energy storage packages that Briggs Stratton is offering. We'll recall some installation recommendations and code-related considerations. This will not be a code-related talk, but we have one coming up soon. So if you're interested in that, please do join our webinar for understanding the code about installing ESS systems. We'll be identifying specifications for 6.6 battery modules and battery stacks, and really introducing that product to you today. And then we'll be summarizing important selling points for battery backup systems towards the end. Let's go ahead and go to the next slide, Mike. Okay, so the agenda here, we're going to start out with SimpliPHI 6.6 battery introduction. So this is the latest lithium battery released a few months ago by Briggs Stratton. We'll talk about the battery backup solutions and how those integrate into backup systems, home power backup systems. We'll talk about the system overview and packages, and then we'll spend some time discussing placement and installation of these batteries. One of the things about these batteries is that they are designed to go in very quickly and easily. We've put a lot of thought into both our wall brackets, our mounting system, and stacking this battery, making it a very easy installation. We'll talk then about how to commission the system, and the word commissioning here in the battery world means getting the system set up for first use. We'll talk about how to stock and sell these battery backup power packages to customers. And then we'll talk about additional capabilities and offerings, things you might want to take advantage of with our energy solutions team. Next slide. So here's a couple of images showing you what the Briggs Stratton battery looks like. These are shown with Sol-Ark 15Ks here in the renderings. And I want to point out that Briggs Stratton is partnering with Sol-Ark here. You've got two American companies. Sol-Ark is a Texas-based company. Briggs Stratton, as you may know, is a brand name that's been around for 115 years, headquartered in Wisconsin. And you're really getting two companies which are dedicated to customer service and the American market, as well as good history of honoring our warranties and being there when you need us. Next slide, please. Okay, so we're going to get into the battery backup solutions that we have, and we're going to start with an overview. So what is a battery backup solution? So a battery backup system uses typically battery banks now with lithium batteries, and the go-to battery chemistry for home battery backup is lithium iron phosphate. So at the core of an energy storage system is a bank of high-capacity batteries that collect energy generated either by the utility or by some other source like a generator, but primarily by the utility. And then in a grid down situation, can release that energy to power the loads in the home. Well, at the center of an energy storage system is something that takes the power coming from the batteries and inverts it from DC current into AC to power the electrical loads of the home in a grid down situation. So there's also an important part of this is monitoring and control, and we'll talk a little bit about our Energy Track app, as well as the My Sol-Ark app that you can use to manage your home power. We're going to talk about two different ways of backing up a home. The first method that we're going to discuss is the lower cost method, and this is for partial home backup. A partial home backup system has been the traditional way that we've done backup just because inverters didn't used to be large enough to power an entire house. Now, however, as you'll see, we'll be talking about packages that can back up the entire home. So a partial home backup system would require movement of some of those core loads, the critical loads, those loads you want to back up from the main panel to a separate panel. That separate panel would stay alive in a grid down event, even though the main panel would go down. And the Sol-Ark will be responsible for managing that connection between the main panel and the backed up loads of the house in a grid down situation. So that dashed line you can see on the screen there is showing it in a grid down situation. That system gets isolated so that we're not feeding any power back through the main panel to the grid and hurting somebody who might be working on the lines. On the right side of the screen, what we're looking at is an entire home backup. This is what we're calling a whole home battery backup system. And we would do this with an inverter like the Sol-Ark 15K. Then the Sol-Ark 15K has a 200 amp pass through. So we'll pass the grid connection there through a fused 200 amp disconnect, a service rate entrance rated disconnect, and into the Sol-Ark inverter. And then notice that the entire main panel in a grid down situation is inside that dashed line, indicating that it's kept alive from that battery bank. That Sol-Ark inverter maintains all the loads in the home, the entire main load panel, during a grid down situation. Now, there are some ways that you can have some of the loads in the home not backed up if you choose to maybe not back up the spa heater or the water heater in the home just for longevity reasons. But for the most part, the Sol-Ark 15K allows you to back up in an entire home, your main loads panel. We'll talk about ways you can do load shedding in more advanced talks. Next slide, please. All right, so why would we choose a battery backup system? Briggs Stratton offers a number of top-of-the-line generators that allow us to do backup, both partial home backup and whole home backup. But there are times when generators might not work as well, and there are even advantages to battery-based systems compared to generator systems. So one might be that a homeowner experiences many outages, frequent outages, but they're just short outages measured in hours of duration. These can be easily covered with a small energy storage system, relatively small amount of storage at quite reasonable costs. Generators often have advantages with longer term outages in that they have an almost unlimited fuel supply. The fuel tank of an energy storage system, a battery system, is the more expensive part, and those batteries are excellent at covering short duration outages. Longer duration outages, of course, get more expensive to cover, especially if you don't include solar in your system. There also might be local noise ordinances. You might not be allowed to put a generator on your system, or you might have an HOA that's prohibiting this. And you might have lot line or just placing considerations that make it challenging to mount a generator. Unlike generators, of course, ESS systems can be installed inside. We don't have to have the concern of fumes, etc. Customers might also not have access to natural gas and propane. The idea of a propane tank in their yard might be something that they want to avoid. And so it's a little bit easier to fit an energy storage system in. Customer might have a desire to add solar in the future, so you can install an energy storage system like those shown on the screen and then be solar ready so that they might add solar a few years down the road, or not at all. But that is an option, and so that could be a reason that customers might choose a battery storage system over a generator. Customer also wants a system that they could expand in the future, and with a battery system, if you get a large enough inverter, you can always just increase the size of that battery bank to a relatively recent amount of time in the future. So we normally recommend within the first 3 years, there's no problem. After that, it's a more complicated decision, just because we don't like to see old batteries paired with new. It puts a little bit more pressure on the new batteries for performance, but you can always expand these systems. Also, you get to do indoor installations with energy storage systems. So this should not be done in a living space, but if you have a utility closet, a garage, even a basement, there are ways that you can install energy storage systems where you wouldn't obviously put a generator. There's also no traditional maintenance required on these battery systems. There's a dealer value add is system testing, so we can do annual system testing and do a battery discharge, even check capacity if we like, but less maintenance than generators. And a customer might only want critical loads backed up and is price conscious. We can do a very small system at a quite reasonable price. So why should we choose a Sol-Ark inverter? There are a number of reasons why Briggs Stratton is partnering with Sol-Ark. One, as I mentioned earlier, it's a Texas-based company. It's a U.S. company. Their inverters have proved dependable. It's one of the most dependable inverters on the market. They're also the largest amount of power in their inverters of anything on the market. It's a next generation transfer switch, so it also eliminates the need for a transfer switch, and Sol-Ark's software does this very well. We call it the Swiss Army knife inverter in that it does almost everything. You can bring in AC coupled solar if you've got an existing solar installation on the roof. You can bring in a generator if you want an integrated generator. You can do a lot of things with a Sol-Ark inverter, and others are still working to catch up to where Sol-Ark has been leading, especially in the whole home backup realm. You've got immediate, seamless backup power with Sol-Arks. We are partnering with Sol-Ark, and we'll talk a little bit more about them as we go through. They are what we consider the best option, the best large inverter for whole home backup. So Sol-Ark is a global energy technology leader. We've got over 6 generations of inverters. They came out with the 8K 6 or so years ago. They've been around since 2013. They've got a track record of results. So for over a decade, Sol-Ark has been solving complex energy challenges with innovation and technology. We have the ability to do 3-phase power. We have the ability to do split phase or single phase 240. It's powered by a vast ecosystem. They've got a large new office. They're growing quickly. They're, again, Texas-based, a broad and ready American-based customer service program, good, solid warranty. And they work with EPCs, integrators, battery manufacturers, contractors. And they also have a Sol-Ark University where you can learn as well. We'll talk about that a little bit as we go forward. They're trusted. They're trusted by global Fortune 500 companies, telecommunications, retail. They are at the forefront of battery backup, and that is the reason that we are partnering with Sol-Ark for this release. Next slide, please. Okay, so we're going to look through an overview of what a system looks like. So remember, this is an introduction to battery backup. What you're seeing on the left side of the screen is the SimpliPHI 6.6 stackable battery. This battery is a 20 kilowatt hour wall-mounted battery. So what you're looking at is a wall mount at the bottom that's labeled C. The battery modules are labeled B, so there are 3 battery modules there. So 3 times 6.6 gives us just under 20 kilowatt hours of storage there. And on the top, you're looking at the controller. We'll point out some of the features of each of these products. D is the inverter, and E is the Energy Track gateway that allows us to do monitoring, remote firmware upgrade, etc. I will also point out that if you want to do a floor installation, we have a floor base as well. So some of the features of the controller, the modules, etc. I'll point out on the left. So starting at the left side of the screen, each individual battery module has a status indicator light on it. That status indicator light lets you know that battery is operating normally. If it's in some type of maybe firmware update, that indicator light on that front will be flashing, indicating that either something is wrong or it's in a status upgrade or a firmware upgrade. On the controller, there are 2 sets of LEDs. The first LEDs that I'll point to are the fuel tank at the top. So that fuel tank indicates 25, 50, 75, 100% level of state of charge of the battery. It also will be blinking if it's in a state of charge to show you where your storage level is, but blinking to indicate where we're filling to. And then on the right side of the screen, I'm going to point out one more LED. That's that power button there, and that power button will do something similar. If there's any kind of an issue, it might be blinking at you, letting you know. But once that is depressed and that battery is on, that should turn a solid green, indicating to you that everything's operating as normal. On the battery modules and the base and the controller, we use these alignment pins to make it very easy to place and position these batteries as we're building the stack. So those alignment pins keep everything centered as we're building the stack up. And then I'm going to point out in the very center of your screen, we've introduced this rapid stack technology. Rapid stack allows you simply to stack the battery, all the communication, all the power, all the balancing equipment. All of this is done through these rapid stack connectors that you can see here, making the build of the battery a very quick installation. Next slide, please. So here's just a look of what a rendering here's a rendering of what the system might look like on a wall. You're looking at a Sol-Ark 15K. They're paired with a 20 kilowatt hour battery stack. That's a system that could be utilized for a whole home backup. This could be installed indoors or outdoors. Again, we've got a little animation here showing how those batteries come together, how that alignment pin on the right side keeps everything centered when you're doing the installation. Next slide, please. We'll talk a little bit about how those batteries go together in the future. I did mention earlier that these are indoor or outdoor rated, and you can either wall or floor mount these. So many of our exterior installations are done on a wall mount. And keep in mind, you do want to install this system on a non-flammable wall, and you want to be a certain distance away from windows and doors. But we also have a floor base option as well. So there are two different base options. You can get a wall mount base or a floor mount base, and both options are indoor or outdoor rated. Taking a look at the specs on the battery, I'm going to point out just a few of these. We're not going to go through all of them. Dimensions-wise, a stack is about just a little over 2 feet wide, 28.6 inches, just a little under 30 inches. So the height of it varies, of course, with the number of battery modules. We can do up to 3. So the largest the system would be was 2.5 feet wide, 7 inches deep, by 5 feet tall if we do a 3 stack. The number of cycles of the system is something that's important. And we talk about using LFP because you get the most number of cycles out of these batteries. You can get 6,000 cycles out of this battery system at a 0.5 charge-discharge rate. You might get more cycles out of the battery if you're charging and discharging slower. So 0.5 C means that the battery will charge by 50% in 1 hour, so it would take 2 hours to charge or discharge. If we're running the battery much faster at a 0.75 C rate, we're still expecting 4,500 cycles. And if you do the math, 6,000 cycles out of a battery is about 16 years. So that's a lot of cycles. And at the end of the 10-year warranty, you're still guaranteed a 75% overall capacity. So if you started with a 20 kilowatt hour system, you're still going to have 15 kilowatt hours of storage warranted at the end of that 10-year period. This battery is also, we're using advanced electrolyte here, and we can charge this battery from 14 degrees Fahrenheit all the way up to 122 degrees Fahrenheit. We can discharge this battery from -4 degrees Fahrenheit up to 131 Fahrenheit. So a broad operational range, and I do point out that charging range. Most of our competitors don't start charging their batteries until 32 Fahrenheit. So we can charge this battery in lower temperatures without the need for expensive and energy-consuming heating equipment. Next slide. So we're talking about chemistry here. I just want to point out that there are lots of different types of lithium-ion batteries. Right, there are NMC batteries, which are more lightweight. There are lithium cobalt oxide batteries, which might be more common in things like power tools. Home battery backup should be done with the safest battery chemistry out there, and that's lithium iron phosphate. You may have seen videos or pictures or even just kind of fear-mongering about batteries catching on fire. Well, those are typically NMC or other battery chemistries. LFP battery chemistry is the safest chemistry that's out there. SimpliPHI batteries that Briggs and Stratton acquired have been making LFP batteries since 2010. So we've got a long track record of safety with LFP chemistry. You shouldn't be using any other chemistry. Daniel.
Yeah, hi. Well, one, I want to encourage anybody who has a question, please put the questions into the Q&A. It's at the bottom. And then Nathan, Briggs & Stratton does make some cobalt-based batteries. Can you talk a little bit about where we also excel in that chemistry?
Yeah, absolutely, Daniel. So there is a time and a place for lightweight batteries, right? And we can do them safely. And our Vanguard batteries are used for things like rental equipment, things like battery power for your lawnmower, things like battery power for operating lights in a construction zone, etc. And there's a time and place for lightweight batteries. And our Vanguard batteries are produced here in the U.S., high-tech factory. And Daniel, you want to mention anything more on those?
No, and I think you hit kind of on the point, is that when it's a home backup battery like we're talking about today, what we care most about is cycle life, and additionally as having something that can be safe on a home, right? So when you're talking about a portable equipment, those batteries are relatively small, but what we're looking at here as we're scaling up these batteries to much larger systems. So truly on a home backup system, really LFP we really find is the best one.
Thank you, Daniel. And I have solved my technology issues and I've got my video going. It might hurt the presentation, but I'm back. So thank you, Daniel. I appreciate that. And yes, I do want to highlight that Briggs & Stratton has a whole line of Vanguard batteries that are out there for other purposes. For home backup, LFP chemistry is the way to go. Next slide, please. So Daniel and I are both trainers. We've got a number of different trainers, Andy Renner. We've got trainers that are going to be in Wisconsin next week. Daniel and I will be running some trainings here in California. So there's a training wall shown there on the left side of the screen. That's a demo wall showing a Sol-Ark 15K with a 20 kilowatt hour 6.6 stack. And you're showing you're seeing that we're demonstrating here a whole home backup in California where there's a meter can, etc. So we'll be running a training next week in Oxnard, California. 2 weeks later, we'll be running one in Sacramento, California. Then I believe we'll be in Arizona soon, and keep up with our schedule in Power Academy. So if you're interested in joining one of these in-person classes, let us know.
And the bottom right is a picture of one of our booths. We attend a lot of not only the regional RE Plus and Inner Solar shows. So if anybody plans to come out to Anaheim coming up in September, we will be there, as well as Sol-Ark. Our booths won't be too far apart. So we're going to have a lot of demonstrations there. And please come by, let us know, and we'll be happy to show you some of these products in person.
It's a nice opportunity to see what these products look like and to ask questions, make some connections with our teams. Okay, so I want to point out that we have, you probably are aware of our Power Academy. We have courses in Power Academy for generators, for batteries, but also I want to point out that there are good courses in the Sol-Ark University. So Sol-Ark offers a whole set of classes called Sol-Ark University. There's a lot of great content there. And we encourage you to go to solark.com, click on the button for installers and navigate to Sol-Ark University. It's free. Similar to our training academy, the Power Academy, the Sol-Ark University offers free courses teaching you how to do installations, teaching you the right way to do it, how to integrate generators, how to work with maybe an existing solar system, etc. And our courses, both of our courses, Sol-Ark's and Briggs & Stratton's, can offer you NABCEP credits for attending these courses. So the Power Academy offers live virtual training, self-paced learn as you go training, webinars like this one. And there's a lot of good content in there. We encourage you to make use of that, learn about our generators, learn about home backup systems. Join us there for that. So let's jump into the packages. I promised to use the time here at the beginning to walk through system packages. So we're going to talk about how much backup time we'll get, how to wire these packages, and what these packages can offer a homeowner. So essentially, we have 3 different types of packages that we're putting in front of you. This doesn't mean that you can't configure a system and design a system yourself, but to make it easy on the homeowner, we're offering 3 different types of packages. An essential power option allows just a small system to be integrated into a home, backing up critical loads. Here's an example of that. So the number of hours we would expect to back up time for an essential system with just a single 6.6 battery is 10.8, assuming that we're going to back up 50% of the loads of the home. So the way we get to this is that the average home in the US draws a continuous, a 24-hour average of 1.2 kilowatts. So we're going to back up half of that. So about 650 watts. And we're going to back up half of those loads. And then in an outage, we expect to get 10.8 hours. You can always add an extra battery, and we'll talk about how much extra time you would get. But for a system like this, we would expect another 10 hours of backup time if we add an additional battery module. Let's look at using a Sol-Ark 12K instead of an 8 in the next package. So a 12K Sol-Ark will give you the ability to back up more items in the home. You've got more power, more ability to bring in generator solar if you want to bring in larger systems. Still, we can't back up the whole home. We've only got 63 amps of pass-through, which means that you wouldn't want to back up the entire loads panel because you would be restricting your service to 63 amps. But you could back up about 75% of the home, get 14.5 hours of backup time with this. With both systems, you can integrate in a generator or solar if you'd like. Let's look at the next option. The next option here is looking at a 3 stack of batteries. That's 20 kilowatt hours of batteries. We'd be backing up the whole home. We expect in an outage, we would get about 16 hours of total backup. We get about 5 hours for each additional battery that we add to the system. Keep in mind that all of these packages include controller, battery modules, a base, either a wall base or a floor base, the energy track gateway, an inverter, which also includes the Sol-Ark app. And then the energy track gateway allows us to have that's the Briggs Stratton app that gives you individual battery module monitoring. So you can monitor all 3, or if you had 6 batteries in your system, you can monitor all 6 batteries individually. So here's a summary of those packages that we're offering. Each one, as I said, includes the energy track gateway that is required for Briggs Stratton batteries, the energy track app, the Sol-Ark inverter, the battery base, wall mount option, a controller. So you've got to choose a floor mount or a wall mount option, but a controller, and the inverter. So we're looking at a summary here, get 10.5 hours of backup time. Mostly we're going to look at the essential power for backing up those important things like the refrigerator, the communications, potentially a TV, internet, of course. Then with managed power, you're backing up most of the home, but you might take off that water heater because you don't need to be heating up the water during the 8 hours or 10 hours or maybe 24 hours that you're out of power. And then for whole home power, you're backing up everything in the house. And you can, of course, add more than 3 battery modules. You can do up to 6 stacks of batteries for that system.
And Nathan, we have a question.
Sure.
So Jeff is asking, is the energy track required when the SimpliPHI is coupled to the 15K Sol-Ark and my Sol-Ark management system?
It is required, and the reason that it is required is that we will need to potentially update the software on batteries. And what the energy track gateway allows us to do, in addition to monitoring batteries and giving feedback to the homeowner and the installer alike, is it allows us to do over-the-air firmware updates. So your question is leading. It brings us right here to this slide. Energy track offers a number of things. So it is required. It allows us to do firmware upgrades. It allows us to monitor. But it's also subscription-free remote monitoring system. And you can do fleet management. So if you're an installer, you can see every system that you've installed. All of these are registered under your company. So it allows you to do fleet management. It allows you to do remote reconfiguration without potentially a need for a site visit. You can do over-the-air firmware updates to ensure that the batteries are operating properly, code compliant, etc. And it
Tech
connects.
support.
Daniel, yeah, definitely
Yeah.
a perk. I mean, with what you can connect either with Wi-Fi or Ethernet. We do recommend Ethernet. Bluetooth connection will be made in the very beginning for commissioning the system. And we'll talk about commissioning here a few minutes later. Sol-Ark offers monitoring as well. Now, Sol-Ark's monitoring of the battery bank is not as comprehensive as EnergyTrack's. You will only get information about the entire bank, but as the center of the ESS system, the Sol-Ark will be your monitor for power. It'll provide you information about how much power you're pulling from the grid, how much power you might be bringing in from a generator, how your battery bank is doing overall, the number of kilowatt hours you've consumed for the month with your loads, et cetera, et cetera. So the monitoring app from my Sol-Ark, which by the way is now housed on US servers, and Sol-Ark owns their app, owns their firmware, et cetera. So they're offering a number of exciting new features coming up. And I'll point the same out for Briggs Stratton Energy Track. Both of our companies are making rapid progress to offer new features. So these are investments. When you do get EnergyTrack, you're getting something that is growing with time and increasing in value with time. Here's a picture of what a system can look like when you're monitoring through my Sol-Ark. You're looking at energy generation. In this example, the customer has a battery system, but they're connected to the grid. They also have a PV system. So what you can see is during the day, that PV is producing, and you see that green line indicating the amount of production PV is producing. And then you can see the battery. When you're getting a negative on that battery is charging. So you see throughout the day when the sun is out, that battery is charging from the sun. And then towards the evening, the sun goes down, the solar production goes down, but they're starting to consume that power that they've stored up in the batteries. And you're seeing the load there kind of taking over the pink consuming that. And then we're going to pull some power from the grid when we're out of battery, et cetera. So you're looking at a monitoring app, and of course, you're looking at a daily consumption. You could, of course, look at a month or a year, or look at total as well. And there are a number of different options that we'll go through in more detail in future trainings. This is really just an introduction here. Let's skip forward. This is the Sol-Ark lineup. These are inverters that Sol-Ark currently has on the market. Our batteries pair with every inverter that you see on the screen here. However, the low voltage batteries that I'm discussing today, the 6.6 batteries, only pair with the 3 inverters on the left. The 2 inverters that are on the right are commercial inverters, the 30K and the 60K, and those take high voltage battery input. So the batteries that you are connecting with the 8K, the 12K, the 15K, the ones that have appeared in our packages, all connect with a 48-volt battery input. That's a 48-volt nominal input. There is, of course, a variation in the voltage as the battery charges and discharges. I point out the number of some important things to point out here. The 8K inverter cannot be paralleled. It is the first inverter that Sol-Ark came out with. You are limited to 8 kilowatts of power inversion coming from the batteries. You can do single or split phase with this, and you've got 62 amps of pass-through. You can bring up to 11 kilowatts of DC PV in, and you can use the generator port to bring in 9.6 kilowatts of AC PV if you would like. So if you would like to use that generator port for AC PV, maybe there's an existing AC solar on the roof, you can bring that in through the gen port, but it can't be paralleled. Both the 12K and the 15K inverters can be paralleled. They can be paralleled to do split phase 240, so that you've got leg 1 and leg 2 at 240, or you could parallel 2, 3, or more units to do 3-phase. So if you want to do balanced 3-phase power, you'd need a minimum of 3 of these inverters. We'll have a training coming up on higher voltage or 3-phase power commercial later next month.
You know, one thing, just looking at this diagram here, these pictures, one, kind of unique physical difference between the 12K and the 15K is the vent fans.
Yes.
And when we're doing these, you can see on that 12K and the 8K, the vent fans go out to the side there. For the 15K, and I believe the 30 and the 60, they vent down. So when we're installing these, I would hope
they vent
everybody's
up,
using
but
the
yes.
installation manual,
Yep.
then more than just a knee pad. Look in the manual and can make those considerations when we're talking about the clearances for venting.
Yes, and the clearances are quite reasonable.
Yeah.
For a 15K, you need 2 inches on the sides, 6 inches below, 6 inches above. And then if you're paralleling units, keep in mind that they do recommend 6 inches between them. We can get into placement later, but I want to highlight one more feature of that 15K, and that's that 200 amp pass-through. So the 200 amp pass-through on the 15K is an important feature that allows it to be used for whole home backup. Whereas the 12 and the 8K inverters only allow you to bring 62 amps from the utility straight through to loads. Next slide, please. All right, so it's important for us to talk about the installation of these systems. We are showing you a wiring diagram here. Notice that there's an extra panel. So you've got your main loads panel in the top right on the screen, an essential loads panel in the bottom right. We are showing you an example of typical wire sizes that are used for wiring up a Sol-Ark 8K, and we'll be sharing these slides with you. The controller does offer you a disconnect. Some AHJs might require a disconnect between the battery and the inverter, and we can offer you some recommendations on different types of battery disconnects, like the ring-con switches to use at relatively low cost if you need that. Showing you the Energy Track gateway here. That's what allows us to do communication, and we're showing you the wiring here. So if you have any questions about that, you can, of course, consult the installation manual. And again, we'll be sharing this slide. Let's see the next one. So managed power is very similar, but we've got more power draw from both the batteries as well as the loads panel. And so we're changing the wiring up just a little bit here. Next slide, please. So we point out here for wiring a Sol-Ark 15K, we do recommend dual sets of 1-aught battery cabling. Those dual sets of cabling can go to each of 2 connections inside the inverter. I'll show you an image of that here in a little bit. But notice the difference. There's now in the top right corner not a main loads panel to the home anymore. In fact, we're just going to pull out of a fused disconnect and power the entire loads panel from that Sol-Ark 15K. Next slide, please. So on relative footprint, so spacing required for this installation, if you really scrunch your system together quite tightly, you can get it into maybe 4 feet wide at a minimum, but typically more like 4.5 feet wide, 5 feet tall, so 60 inches tall there on a whole home backup system. Showing a number of examples of where this might be mounted, some nice renderings here. And we encourage you to do a thorough layout with a homeowner before coming to do the installation, so they know where it's going to be. And hopefully we'll have some software coming up that'll help you visualize how that system can be installed. Keep in mind that an ES system is intended for installation in non-habitable spaces. It should not be installed in a living room, a kitchen. This should only be installed in an electrical utility closet, potentially a basement, as long as it's not a basement intended for, built out for living. And a garage is the most common space, although we see plenty of installations occurring outside as well. Next slide, please. There are national electric codes so that you should be following, and the NFPA 855 is the standard that the NEC requires you to follow. So the NFPA is the National Fire Protection Association. 855 is the code for installing energy storage systems. We have a talk coming up on this. We're just trying to make you aware of this. We are also a heavily safety tested company. We very much believe it's important to do the safety testing, and we have all the appropriate certifications on our battery. Those are done by UL, which is an independent testing agency that you probably are aware of, that does safety testing on battery systems as well as other electrical systems. Next slide, please. When we are installing in a garage, if we're installing in that rear wall or certain locations in the garage, it's important that we install our battery in a manner that it cannot be run into with a car. It cannot be crushed by somebody hitting the gas instead of the brakes when they're pulling into the car. And so parking ballards might be required depending on where you install the system in the garage. Daniel, you want to talk a little bit about this slide?
Yeah, I think kind of my takeaway on this slide is, we're all pretty used to the NEC, the electrical code, but there's a lot of new building codes and fire codes that are coming into play with these energy storage systems. And sometimes these codes require us to maybe add drywall, parking bollards, like you see there, prevent someone from crashing into heat detectors, not necessarily smoke detectors. And a lot of these can add cost to the system that may not be hopefully anticipated at the beginning. So like Nathan had said, we have an upcoming codes class that's going to dive pretty much deeper into some of these building codes, not necessarily the electrical codes. So there's codes around how much energy storage you can put in any given location. There has been some recent updates, at least here in California. So join us. Make sure you check your email for some of these. We got it coming up next month. But absolutely, the takeaway here is that what we're trying to do is encourage and ensure the safety of not only mainly the occupants of the house, but also the property as well. So join us for that talk and keep a lookout for that invite coming up.
And just like the NEC, which gets updated every 3 years, the NFPA 855 is in a revision as well, and we will keep you up to date on that. So please join us for that codes talk if this is something that you need a refresher on. Let's get into the operator's manual, which will talk to you about how to install a system. So I'm going to show you some images of what it's like to install a battery system in the next few slides. So the battery itself has a base, and that base can be a floor base or a wall base. If it is a floor base, you secure it to the floor. If it's a wall base, you secure that base to the wall. You'll certainly want to make sure that you find your studs, bring a stud finder when you're doing this installation, and you're going to center that battery system between two studs if you're installing on that type of wall. If you're installing on CMUs, of course, you'll want to bring the appropriate anchors to run into CMUs, like potentially Tapcons or even expansion bolts, depending on what you're installing to. There is a rack that goes behind the battery. Now, you don't see it in any of the installations because it is hidden, but that's there to secure that battery to the wall. One of my favorite features of that bracketry that goes on the back is that we've
the hidden logo.
Cut the Briggs and Stratton logo into those. Yeah. And though this system includes a rack, the installation can still happen in a very reasonable amount of time. I think the last install I did was a couple of weeks ago where we put this on the wall. We built the entire battery bank in probably 30 minutes, maybe even less. So it goes up quite quickly, but you do want to make sure you get it right. You'll want to have a level there on site, make sure you get your racking straight up and down, have everything plumb, level, etc.
I think that oh, sorry, Nathan.
Go ahead. Go ahead.
I was going to say, I think what we're looking at here is kind of representative of the engineering that Briggs & Stratton does put into some of our products. I've seen some of our competitors that have little L brackets that are holding the battery up against the wall. And what we're seeing here is although, yeah, there's a little more construction available, but it really shows you that what we're doing is thinking through a lot of these engineering design challenges and providing you, the installer and the homeowner, something that's going to really be secured. And Nathan, if you want to talk a little bit about our seismic testing as well.
I'll talk about those wall brackets just for a second. A lot of the competition has got a wall bracket that is in a single location at the very top of the battery. And the only thing holding that battery on the wall in the event of an earthquake, and many times it's positioned in a place where you can only put a drywall anchor in, right? That's not going to get you through an earthquake, right? And with a lot of installations occurring in earthquake zones, people want to put these on tiny homes and drag those down the highway. It's important that you have a solid bracket like this. We've gone through Category 9 earthquake testing with this and passed with these wall mount brackets. So it is important to have this done right and safely. Let's move to the next slide so you can see what it looks like to put the battery on these brackets. So the battery brackets we've got a horizontal retainer and then the vertical spacers that are there. And so when you're stacking this system up, there are some side panels that go on the batteries that hide these connections that slip on over the top. But what you can see is that there are shoulder screws that attach to the bottom and top of each battery module, securing them to the wall. There are also tab screws that go between those alignment tabs and the battery module or the controller above it. And so everything is connected together with these machine screws and with these shoulder screws, and the whole system is securely mounted on the wall. So the top right, you see a tab screw going into the top of the controller. Bottom right, you see a tab screw connecting the floor base with the battery module above it. And then in the center, you can see those shoulder screws connecting the battery modules to the ones above and below them. And then to complete the battery build, after you've stacked the batteries, attached them to the wall brackets, the floor base, you just slip these covers over top. Those covers are designed for a slip fit. Takes about 60 seconds to put all 6 of those on. And then you've got a completed battery. So here's what a battery looks like all complete. There is a top wiring bay, and this is where your final connections will be made. This is the only wiring that has to occur on this battery. What you see in the center of the screen there, in the top center, is the wiring bay. Now you could have 2 sets of cables coming off those battery lugs, or just 1 set, depending on whether you're going to a 15K or a 12K, etc. You also have 2 communication wires. One communication wire, the one on the right, the black one there, is running to the Sol-Ark inverter, and I'll show you a picture of how that connects to the Sol-Ark in a later screen. And then one on the left, the white one, is going into the energy track gateway. If you are doing an outdoor installation, you'll want to make a waterproof connection. I'm showing there with a seal-tight connection on the, I'm sorry, not a seal-tight, rain-tight connection. And that connection is made to the inner cover plate. There are 2 cover plates that go on the side there. And then the last one that you'll put on top is that top plate, which makes the connection that covers the top of that wiring bay. And then the outer cover just slips on over it. So you've got a kind of shoulder cover that slips on over and then fastens with a screw to the top plate. So the connection is relatively straightforward there. I'm not showing the cleanest installation on the right. That's one that I built for a training wall. So it's not as pretty as it could be. You can make it look much nicer, but that one is done so that we could have essentially an extension cord that will plug into any of our training walls. Next slide, please. So how do we connect the battery system to the inverter? So as I mentioned, out of the wiring bay on the battery, you'll have 2 communication cables. One will run to the energy track gateway, and the other will run to the Sol-Ark inverter. Coming into the Sol-Ark inverter, we will come out of the CAN port on the right side of that wiring bay through a 90-degree dongle, which is included with the controller. It's not something you have to source. And that'll go directly into the Sol-Ark battery CAN communications port. And then for the energy track gateway, you'll use an Ethernet cable to run into that dongle, and that runs into the CAN bus port on the gateway. So all of those connections are included with a controller. Let's go ahead and go to the next slide. So here's the inside of a Sol-Ark. This is a Sol-Ark 15K. The 12K and 8K look similar with a little bit, they only have 1 battery connection each. So I'm going to point out some things on a Sol-Ark 15K. Keep in mind, this is only an introduction, and I've only got about 11 minutes left, so I'm going to be careful on time. We've got DC breakers on the left that will connect and disconnect your battery if you need to isolate the Sol-Ark for any reason. The battery connections, you've got dual sets of battery cables on a 15K, and that's why we recommend dual cables coming out of the battery. Each of those are on independent 200 amp breakers. You can have a maximum amount of current coming in of 275 amps on a Sol-Ark 15K. What you're seeing, orange and green there in the center of the screen, those are the DC PV inputs. So you can connect your solar array directly into those 3 independent MPPTs. You can parallel right there, bringing 2 sets of solar, 2 strings of solar into each MPPT if you want to parallel at the inverter here. If you want to parallel multiple inverters, top center, there's a way to parallel the communications. And so you could have two 15Ks backing up a larger house if you need that extra amount of power. The battery CAN bus we showed on the previous screen comes into the control board there in the center. And then we've got three AC ports on the right side. So the first one going from right to left here, we've got the grid input. So that's going to come from your 200 amp service disconnect in here. You can pass up to 200 amps through the loads port. So you can see a disconnect there. So you've got a 200 amp. I don't believe it's a breaker. I think it's just a 200 amp disconnect. And that you can have 200 amps go out to loads. The generator input is on a 100 amp. It's got a 100 amp breaker to it, or a 100 amp limit to it. It's 80 amps continuous there. And then you've got the neutral and the grounding bars at the bottom. So that's where you will bring your 3-aught, likely 3-aught copper into 4-aught aluminum into. Next slide, please. So when wiring a 15K, we want to highlight that we do have combiners available if you want to connect. So if you're doing your battery cabling free air, you could just run a single set of 4-aughts in free air into a Sol-Ark 15K and combine the positive and negative inputs. Briggs Stratton has combiners available if you want to do that. However, the recommended way to connect is using dual sets of cables. So if you have two battery systems, so double stacks there, you would have one set of cables from each battery, both going into the 15K. If you have a single battery, we recommend dual sets of 1-aught cable going in one to each of the battery connections as well. Let's skip through. I'm going to try to...
Real quick, Nathan, future content coming is certainly the install that you recently did, showing a Sol-Ark installation with a full battery stack. So we have a lot of great content coming that Nathan was able to capture, including this particular installation. You can see some of the status LEDs, the working Sol-Ark system, and more content from Sol-Ark to explain how to navigate the system menu of the Sol-Ark inverter and the proper settings for commissioning, as well as another training video with that training wall that Nathan referred to. Nathan and an engineer from the Oxnard team in California walked through the basic process and show how easy it is to stack these batteries. And over the last few months, we've gotten faster and faster on that time, certainly. But we stepped through the process of installing the mounting brackets, setting the batteries, and then connecting to your inverter of choice.
And you'll find all of that in the Power Academy in the coming weeks here. So thank you, Mike. So let's talk just a little bit in the last few minutes that we have about commissioning a system. So doing the final settings of the batteries is relatively easy. Setting up this monitoring platform should take you, it takes me normally about 5 minutes, might take you about 10 minutes to walk through the commissioning of the batteries. You'll also have a separate commissioning of the inverter that's done through the My Sol-Ark app. Both are relatively quick. So to set up Energy Track, if this is your first installation, you'll want to make sure that you create an Energy Track username prior to going out to the site. And so we recommend that you do that at least a business day prior to your first installation. Once you have your first Energy Track account created, so you created an account, once you have your first account created, it's a pro admin account, and that pro admin account can create more pro admin accounts. Or we can also use that account to create a second level and a third level of accounts. So we have a technician account, which technician accounts are able to create homeowners accounts and to install systems, but not to manage the company accounts. And then we have homeowner accounts, which are normally created during configuration, during commissioning process. So the steps here are to create a new site. Then you'll click on Start Commissioning for that site. You will confirm that all of your batteries show up. Everything is relatively automated. You'll confirm that everything shows up in the system. And then you'll confirm system operation. Within about 60 seconds, you'll start getting information about the telemetry that your batteries are reporting, et cetera. The states of charge, the state of health, individual battery information on that battery tab, et cetera. Let's go to the next slide. Short on time here, but for pro users, you get all this ability to fleet manage. Again, all of this is free, but the Energy Track allows you. So we have 3 different user roles, as I mentioned. but it allows you to monitor all the systems that you have installed previously. And this is a nice feature. If there is any kind of issue with any of the systems that you've installed, you can contact that homeowner and be proactive about maintaining that business. And I think homeowners really appreciate that. Next slide, please. So we're going to talk just a little bit, maybe 2 minutes on stocking and selling the battery backup power options, and then we'll take some time for Q&A at the end. Mike, do you want to do this?
Certainly. So as we've shown, the basic items needed for a battery backup system start with the 3 major components of the battery stack. There is a maximum of 3 battery modules per stack, but the controller, the battery module in quantities of 1, 2, or 3, and a base option. And what we're showing here are the internal Briggs & Stratton numbers. Those that are installers or dealers for us can order the batteries through the power portal or through your local sales team members. But paired with an inverter of choice, we have the Sol-Ark's 8K, 12K, and 15K option available. And on our price list, we have those packages that Nathan walked through before. But as he also stated, multiple batteries can be configured with either choice. So you could do 2 batteries with an 8K or 3 batteries with a 12K. And lastly, as you're adding to your shopping list, the Energy Track Gateway listed here, you would order 1 per full system. So an ESS system could be multiple battery stacks, single battery stacks, or multiple inverters, but you just need 1 Energy Track Gateway per system.
So you can have up to 18 batteries on a single system. That's 6 stacks of batteries, single Energy Track Gateway needed. If we're ordering and we're trying to stock this equipment, Mike, how much can we fit on a pallet? How does this ship?
Certainly. So some options to consider as you think about stocking your warehouses to provide battery backup options for homeowners. One option might be 2 full stacks can fit on a single pallet. That would be 6 battery modules, 2 controllers, and 2 base options, either the wall or the floor. If you'd like to stack individual quantities of just batteries, just controllers, just bases, we can fit 8 battery modules, including the mounting hardware, on 1 pallet, 12 controllers, and 20 bases per pallet. And some of the early options or the early installs where the mounting hardware came separately, those will be included with the battery modules going forward. Also available on the Power Portal, our Briggs & Stratton dealer portal site, is marketing collateral, whether it be digital advertisements, images and logos, or spec sheets and sell sheets. So we wanted to update the existing team that there are new things out there on the Power Portal. If you navigate to the custom marketing site, you'll see these tiles and icons to pick from, indicating assets that you can use to advertise through your social media platforms of choice or on your website that you now offer Briggs & Stratton backup power energy storage options in addition to generators or vice versa. Leveraging the American company of Briggs & Stratton and certainly the industry-leading warranties associated with some of our products. We also have a digital collection and more growing every day of digital assets that you can use to highlight the energy storage and battery backup options that Briggs & Stratton offers that you can sell to consumers. And as I mentioned before, sell sheets and spec sheets highlighting the different package options that homeowners can consider as you're going out to quote the battery backup needs that they may have.
So we wanted to take an opportunity here to do some Q&A. So if you do have questions, feel free to pop them into the Q&A.
Yeah, we do have one.
Okay, go ahead.
And I think this is a great question, and it's from Jeff, and I think he's really thinking about the details. And Jeff asks, when using 2 battery stacks, is it required to match the DC cable links?
Yes. So we want to. So, and the reason for that, Jeff. So great thinking.
Yeah.
The reason for that is that the batteries themselves are outputting large amounts of current, and we want to balance that current as well as we can coming from both stacks. So if I got stack 1 and stack 2 both feeding an inverter, and I have a really long cable length on stack 2 and a short one on stack 1, stack 1 sees a lot less impedance, a lot less resistance to the flow of the electricity out of its bank. Stack 2 sees a decreased voltage at its terminals, and so it's outputting less current than stack 1. And so by matching the battery cable lengths, what we're doing here is balancing that load between those batteries as best as possible. So yes, it is necessary to have equal cable lengths on battery stacks. Great question.
Yeah, we just got another one, and please keep them coming. Chris asks, understanding all houses and installations will be different. What is the ballpark installation time frame for a 3-battery stack, including commissioning and wiring?
So that's a great question. So every installation, every installation I've been part of, there are always some challenges to work through. So that installation that Mike showed a video of that I did together with some local electricians, it took a full day to put that system in. And then we ended up coming back in the morning to wrap things up. The reason for that is that Sunrun had done quite a job on the solar input on the outside of the home, and we had to take off a lot of that. If you are simply putting an inverter on and wiring it in for new construction, I'd say that you can do it in half a day. The battery system will go up in place in about 30 minutes. The wiring between the battery and the inverter might take you another 30 minutes if you're making up cables, etc. The inverter connection to the main loads panel and working with heavier cables like 3/0 like that, as you all know as installers, does take some time to get all of that right. So I expect that a fast installation would be half a day. And that would be for new construction. If there's any types of challenges that you have to work through, such as old equipment that needs to be removed, etc., I would budget a full day, kind of at a minimum.
Now, Robert, I saw that you had raised your hand. We can't answer it, so please put your question in the Q&A chat, and we'll do that. Nathan, just kind of my final thoughts is we refer to these batteries as battery backup, and I know we're running out of time here, but think of the batteries, it can be more than just battery backup. Of course, you can set the reserve level to these batteries, but if you live in locations that have interconnection policies that require time of use, you can discharge these batteries by low, sell high. So unlike a generator, these things aren't just sitting there. They're able to be a grid interactive device. So you're getting more than just the backup. Of course, that's a big selling point. Also, additionally, you can qualify for some 30% tax incentives on this as well. So
and that's a huge thing, Daniel, and that's available for anybody in the US, right? Is a 30% off. It includes the installation, it includes all of the equipment, even the wiring required to do this. 30% off that installation
and labor.
Cost, and the labor, but there's also additionally local incentives available as well. And what you mentioned about energy arbitrage, one of these systems, so one of my favorite things about an energy storage system is that there's no loss of power in the house. There's no delay between, backup power kicking in. Basically, just everything keeps going seamlessly. So I love that about it. I also like the fact that you can bring in things like solar and generators into these systems. So if you're in a location where you get outages that are a week long, you might want to integrate a generator in addition to a solar system so that you can get through long outages with a generator, or you're living off grid. You can integrate a generator and a solar system together. That reduces the runtime on the generator, reduces the fuel use, the maintenance cost. Your batteries
coming up this
low.
Thursday. Yeah, coming up this Thursday, we're doing a generator talk. It's
Absolutely.
NAPSEP. You can earn a 1 hour of credit on NAPSEP, and we're going to address exactly what you were just talking about, Nathan. I don't see any more questions.
Yeah, so I want to thank you for your time today. We did go a little over with the Q&A here. Greatly appreciate your attention. Encourage you to pay attention to what is being released on Power Academy and upcoming trainings like the generator integration. And no, the answer, Jeff, to the Briggs Stratton generator cannot be included in the rebate. It's only for renewables. But thank you, everyone.